Hello everyone! This lesson will introduce you to classical ciphers. In this lesson, you will learn about the Caesar cipher, the Vigenere cipher, and more generally about substitution and transposition ciphers. Cryptography is an advanced field that involves math, informatics, probability theory, and even physics in modern times. So it's an interesting feeling to recall the time when cryptography was an art performed by hand, known to few. Classical ciphers are those invented before the computer era, before electromechanical encryption machines like Enigma, the so-called pen and paper ciphers, and were widely used up until World War II. The Caesar cipher is one of the earliest known and simplest ciphers, named after Julius Caesar, who used it to communicate confidential matters with his circle. The idea is simple. Each letter in the message is shifted a certain number of places down the alphabet, and the key is the number of places the alphabet is shifted. Records say Julius Caesar himself was using a shift of 3 places, so A would become D, B would become E, and so on. In general, the shift can be any number up to 26, which is the length of the English alphabet. Let's try it with a shift of 4. For clarity, construct the replacement table that contains for each letter the letter to be substituted for it. And encryption is a simple replacement. A message encrypted this way looks totally scrambled, and at the time, most of the Caesar's enemies were illiterate or would assume that the weird message is simply written in foreign language, offering reasonable protection. But the Caesar cipher is in fact very easy to break. Just try different shifts of the alphabet until you get a readable message. This example from Wolfram function repository does it in a matter of seconds. Another famous classical cipher example, the Vigenere cipher, comes from the 16th century. It is similar to Caesar cipher, but instead of adding the same number to every letter of the plaintext, it adds the index of each letter in the keyword, like lemon, to the corresponding letter index of the plaintext. If the message is longer than the key gets repeated as many times as needed. So here attack on the first column would be plaintext, lemon would be key, and the third column would be the resulting ciphertext. You can try Vigenere encryption and decryption with this implementation from Wolfram function repository. The Vigenere cipher is essentially a combination of Caesar ciphers with different shifts for each letter of the plaintext. The Caesar and Vigenere ciphers offer no communication security in computer networks, but their simplicity for humans renders them still useful for peer-to-peer covert messaging. They are known to have been used for field communications between soldiers in many wars, between members of criminal gangs, and between mafia bosses even nowadays. Caesar and Vigenere ciphers are a specimen of a more general class encryption methods, called substitution ciphers. Each symbol is replaced by another symbol, and the key is the permutation of the alphabet used. Encryption is a simple replacement, and the decryption key is the table of reverse substitution rules. Using these rules, each letter of the encrypted message is replaced back to obtain the plaintext message. The analysis of frequency of various letters provides enough information to break substitution ciphers, given a few hundred encrypted symbols. The records of this technique date back to the 9th century. In English, the letter E is the most frequent, so if an English text is encrypted with a simple substitution cipher, the most frequent letter is assumed to stand for E, and so on until the parts of the ciphertext become readable as more and more letters are guessed. Another class is transposition ciphers. Symbols in the plaintext are rearranged according to certain rule. One of the most ancient examples of a transposition cipher is a skytale, used by Greeks and Spartans. They would wrap a strip of parchment around a rod and write a message on it. Here is how a message "meet me at noon" would look on a skytale. The encrypted message on the unwrapped parchment would then read M, H, Y, and a bunch of letters, and the receiver would need a skytale of the same diameter to wrap the parchment around and decrypt the message. This same algorithm can today be written with the Wolfram language with the help of array reshape and transpose. As you can see, unlike substitution ciphers, the letters are not replaced with other letters. They are the same letters, just arranged in different order. For the ancient Greeks, the key to correct the order was the diameter of the scutali. In this example, it's the dimensions used in array reshape. Formally speaking, a transposition cipher can be any random permutation function of the plaintext as long as the receiver knows the inverse permutation. Like this message is easily decrypted by knowing inverse permutation. The obvious flaw of encryption by permutation is that the ciphertext always contains exactly the same letters as the plaintext. To an attacker, the ciphertext is a jigsaw puzzle that reveals the secret message once the letters are assembled correctly. For this task, they can use the tables of pairs of letters and triplets and n-grams frequencies for a language to arrange the ciphertext characters in such a way that they form some n-grams with the highest frequency until the transposition pattern is found by trial and error. Over centuries, people have invented many possible ways to break through the classical ciphers, from manual analysis to neural networks. The ciphers described in this lesson have been obsoleted by strong algorithms optimized for modern technology, but the core idea behind them have shaped secret communication for many centuries. In 1949's Communication Theory of Secrecy System, a foundational work of modern cryptography, Claude Shannon proposed that effective encryption system could be built by repeated application of classical substitution transposition operations, or confusion and diffusion in his terms. This principle is employed in ciphers to this day, including the famous US standards of encryption DES and IIS. The rest of the course will focus on the modern cryptographic techniques used in practice, approximately in the last 50 years of field's evolution, paying tribute to the ideas taken from classic ciphers where applicable.